Thank you. This is my entry for doing cool things with a Tektronix oscilloscope. Today I'm building a pulse induction metal detector. And what we have here in the picture is we have the coil of the metal detector, and in the background my very own Tektronix 453 bone anchor slash transistorized slash I need a new oscilloscope please. So what we have right here in the foreground is we have approximately 6-inch diameter coil that's been manufactured here to give a very fast response, hopefully to look for some gold later on here in the state of Arizona. And what we have down here is a Tektronix 453 with the said waveform on it. Now this is the amplifier board. Coming in through this coax cable here is the coax cable to the coil. Here comes in the signal from my from my square wave generator that sets a 50 microsecond pulse followed by about 450 microseconds of silence. It goes into a MOSFET driver. The MOSFET is located approximately here but underneath the board. A couple of power supply filters, a couple of voltage regulators to steady the voltage, a potentiometer to adjust some op-amp offsets, and right here we have an LM318 op-amp which amplifies a signal at about 8,000 to 1. So what we have here is my lovely Tektronix 453 oscilloscope. For those of you who like a little bit of history behind things, this was one of Tektronix's very first all-transistorized non-vacuum tube oscilloscope back in a long time ago. That's not actually entirely true. This oscilloscope does have two new Vistors on the front end of it from what I understand. But in a shameless plug, I hope that you guys award me the new oscilloscope so I can replace this boat anchor. I'm ready to take it fishing. So what we have here, the top trace is the charging of the coil on the metal detector. This is a pulse induction technology metal detector. So we set up a magnetic field within the coil, and then we suddenly cut it off and we listen for the eddy currents being rebroadcast by the excited metal objects that would be within the coil's field of view. On the second line we have the decay curve of the coil. Now this is a standard pi construction of a pulse induction metal detector. So what we'll see is we'll see the front end has some diode limiting or some voltage limiting diodes to squelch the flyback current, which is in excess of 400 volts on this. So what I will do now is I will take a very large metallic object, just for demonstration purposes, and I will pass it back and forth over the coil of the metal detector. Now with that being said, you can watch the curve change, and I'm going back and forth. And here I'm in the coil, you see it flatten out, and then it's back out again. So here the metal object is within the coil and back out again. So when you're looking for things with metal detector, while a big utility knife may be a little exaggerated, we can do this. It looks like that. So you can have your favorite analog circuit or digital circuit process that information and determine if you have a metal object in there or not. So that is the cool thing that I can measure with my Tektronix 453 oscilloscope.